Now I will describe about the major components of OES one by one. OES has three major components: a high voltage electrical excitation source for introducing energy to the sample. Excitation sources are of two types: spark, discharge or arc generated from a high voltage DC source, and inductively coupled plasma. The spark or discharge is generated between two porous electrodes of graphite in case of lube oil spectrometers, one being the disc and the other being the rod. For oil analysis spectrometers, a large electric potential is set up between the gap existing between these electrodes, also called as rotorods. The oil is kept in a high temperature sample cup. In case of metal spectrometers, the spark is generated between the metal sample to be tested and the tungsten electrode through an orifice of 0.5-inch dia. Normally in railways, we use spark or discharge type excitation source. The arc or spark from the source is shielded in an inert argon atmosphere created with argon grade 5 having purity 99.9998 for equipments used for testing metals, while no such provision is required in case of oil spectrometers. Because in case of metals, impurities such as carbon, oxygen present in the atmosphere may affect the readings, while during testing of lube oil, the lube oil medium itself inhibits any contamination from the atmosphere. The second component is the optical system, which contains a diffraction grating which separates the light emitted by different elements into element-specific wavelengths. Photomultiplier tubes or charge-coupled devices to generate electrons depending upon the intensity of dispersed light. Capacitors to store the charged electrons discharged by the photomultiplier tube. The third component is the computer readout system, which converts generated voltage into digits and finally gives result in either ppm or percentage. It detects and measures the light that has been separated into its component wavelength by optical system and presents this information to the operator in a usable fashion. A specific calibration program is applied to raw spectrum using regression analysis to achieve the desired results.
Now I shall describe about the step-by-step working of two most common type of spectrometers used in Indian Railways. Starting with the oil spectrometer, also called as rotating disc electrode spectrometer. For oil analysis spectrometers or rotating disc electrode spectrometers, oil is drawn through the outer circumference of the disc electrode when a vacuum is applied to the inside of the electrode. Meanwhile, a large electric potential is set up with the help of the electrical excitation source between the disc and the rod electrodes, with the oil sample between the gap in between them. The electric potential generates arc or spark, which vaporizes a part of sample forming plasma. Plasma is nothing but hot and highly ionized gas which is electrically neutral and emits intense light. This intense light travels through the fiber optics cable and goes to the optical chamber, where it strikes on the grating. Light radiation corresponding to different wavelengths and different elements is segregated by means of grating in the optical system and converted into a continuum of electrons or electronic signal based on their intensity in the charge-coupled devices. These electronic signals are interpreted in the computer readout system and compared with the help of regression graph obtained by calibration of the instrument with known standards. The entire process takes up to 45 seconds of time, and the processing time depends upon the wear metal size. Concentrations of wear metals in the level of ppm are obtained. A rotating disc type oil spectrometer cannot identify wear metals of size larger than 10 micrometers, a drawback which is being addressed in ICP type or inductively coupled plasma type rotating disc electrode spectrometers. Now we will learn about the step-by-step working of a metal spectrometer. First, the sample is cut into the required size in a specimen cutting machine. Then it is grinded on a grinding machine using grade 60 to 80 size emery. Then the vacuum pump is switched on. A vacuum pump works to remove atmospheric gases from the OES system. Then the argon pressure is regulated. It should be between 3.5 to 5 bars. Argon purging is done through the optical chamber to flush any remaining atmospheric gases in the area between the optical system and the excitation chamber of the sample stand. The argon gas should be supplied at a pressure of 80 to 120 psi. Then the device and the readout computer system is switched on. As can be seen on the computer system screen that the computer system contains pre-installed OES software which will be further used for spectrometric analysis. Then the sample to be tested is placed on the sample stand and is clamped. The sample is burnt and the results are obtained in the computer readout system. We must ensure that the burn is proper. The sequence of operation should be start, flush, pre-burn, measuring, that is, analyzing the composition, and finally getting the results.
Now I will describe the factors for reliable working of spectrometer. The foremost factor is the environmental condition in which the spectrometer needs to work. The room temperature should be maintained between 18 to 25 degrees Celsius, and therefore provision of air-conditioned room is a must for proper working of spectrometer. Similarly, relative humidity should be maintained below 65%. The second most important factor is the stability of electronic circuit. The voltage source of 110 to 220 volt with uninterrupted power supply should be maintained. If required, power backup will be needed. The third factor affecting the reliable working of the instrument is the proper initial calibration of the equipment and subsequent standardization. In case of oil spectrometer, the standard solution for calibration shall be homogeneous and uniformly viscous. Now I will describe about some general consideration about the sample preparation. Normally the metal sample to be tested shall have a diameter of 16 to 15 mm and thickness up to 25 mm. However, samples having half-inch flat and homogeneous surface and at least 0.01 inch thickness can be sparked using a metal spectrometer. In case of oil spectrometers, 2 to 3 ml of thoroughly mixed and uniformly viscous oils can be used for getting good results. In case of metal spectrometers, close burns like these should be avoided, as they may interfere in getting right values. However, distant burn like these can be preferred. Now we will learn about the calibration and standardization of OES. Calibration of the instrument is normally done at the time of commissioning by the OEM representative. However, standardization of the OES machine should be done daily or at least after every 4 to 5 hours of continuous operation to maintain its accuracy. Three types of standardizations are normally recommended for OES. They are single point standardization. Single point standardization is done using single standard and is advisable when the sample to be tested and standard available are of similar chemical composition. Double point standardization. Double point standardization employs two standards of low and high values respectively and is preferred for re-establishing the position of calibration curve. Type standardization. Type standardization is the usual method adopted for standardization where the instrument is standardized with a sample having pre-established composition. For calibration of oil spectrometers, oil standards having metal concentrations of 0 ppm, 10 ppm, 30 ppm, 50 ppm, 100 ppm, 300 ppm, and 500 ppm are sparked, and results are used for calibration using regression analysis. The best way to standardize the OES is with certified reference materials, which are made and certified by a recognized certifying organization using approved certification procedures as instructed in ISO Guide 35/2006, which is Certification of Reference Materials, General and Statistical Principles. Materials produced or certified by National Metallurgical Laboratories, that is NML, such as NIST, are automatically CRM by default authority and therefore can also be used. Hope the video was informative and helped you better understand the OES and its significance in Indian Railways. Thank you.